Okay, guys, so I just worked through problem number 4, and I'm angry because it's honestly way more simpler than I even realized. Like, I stared at this problem for a long time thinking, oh, this is so complicated. And honestly, it's infuriating how simple this is because this means I could have done this at any time. So, on midterm number 2, you have this little block diagram and you have these three systems that represent this. Uh, what this block diagram is saying, and the only reason why this is important, is because these two are convoluting. Well, this one, see the plus sign here, it's a sum, right? So convolution plus a sum. Literally, an elementary student could do this. So I'm going to make some charts, some convolution charts. All right, first start off with S1 and S2. They're going to convolute. This is insultingly easy, right? Do a 1 and a 2, and then a -1 and a -2. You guys can do your convolutions using this kind of chart. Either one is fine. See, this one you do a diagonal chart. This one you go down, but it's shifted over one. Depends on the type of question. I find sometimes this is easier, and then if it's sometimes it doesn't matter. Anyways, and then you just do diagonal sum. 1, -2. So that is going to be, that is your system 1, 2, right? Now, you saw in the problem there was a sum. You just take this system and you just add it to this one. So you're just adding these ridiculously small numbers. Like a 5th grader could do this, right? So now that's the end of the block diagram, the end of the function. Oh, and the question's asking, what are the coefficients? Well, you're just finding out these numbers. So your coefficients is 2, 3, 1. Right? So I'm not sure. Basically, your answers either going to look like you got D0, D1, D2 equals 2 equals 3 equals 1, or you might want to rewrite the problem, and it's going to look like this. And then that's going to be plus 3x n minus 1 plus, and then you can say x minus 2. Remember, we have a imaginary 1 here. And then this is your answer. That took me 3 seconds. And a 5th grader could do that.